Good morning, sweet peas. So this is Monday, and we're going to do two lessons this week. The first lesson we're going to do is on exponential functions, and I believe it is on page 51 and 52 in your pink book, so get that out. If for some reason you don't have your pink book, I'm going to upload this page that's in your pink book right into Google Classroom. So we are going to start by using these first two examples right here. One on biology, which is very similar to what's happening right now with our virus, unfortunately, and another one on waste. And then we're going to pause, and then I'm going to let you try to do this one on learning, and then I'll come back and show you a response. All right? So that's how we're going to do it. Again, we're going to be on page 51 and 52 of your pink book. So if you would go ahead and get those out. And it's going to be possibly a little bit awkward at first. So we're just going to do our best to make this work. And here's what I'm going to do. I've got on my screen, I have your page 51 on exponential functions. And then over on the side, what I've done is opened up a graph in Desmos. So if you will probably have this bookmarked, but go to desmos.com /calculator. And we're going to be looking at the graphing calculator portion of Desmos. So either on your phone, if you have that free app, or if you have Wi-Fi, right here on another tab, just open up another window. And if you don't end up having this, you can do it separately. You can watch me, but it would be really good if you would go through this with me. So, all right. Let's start by looking at the first example, and hopefully this will work. So I'm going to open up this page, and we're going to see if our browser will work, and hopefully it will. All right. So in our first example, it's on biology, and exponential functions are a new kind of function for us. We've looked at linear functions, we've looked at quadratic functions, but exponential functions behave differently. And we're going to try to figure out what the equation looks like, what the graph looks like, what the table looks like, and then what words look like. So our four-way representation that we've looked at in linear and quadratic, we're going to look at that again in exponential. In this example, we have biology, and it says, suppose a certain cell reproduces itself in 4 hours. 4 reproduces itself. All right. Use the, and then I'm telling you, it's an exponential function. And so if you've got your highlighter, you might want to just kind of make a note here. Hey, here we are. Okay. And then here it is, f of x, which you know is another, just a fancy way to say y. F of x equals 5 times 2, and then 2 is the base, and look who's the exponent right here. Not a number, not 2 like we saw with quadratic, but x. X is in the exponent spot. And so that seems to be a difference than what we experienced with linear or with quadratic. X is now in the exponent spot. So let's see what happens. Okay, 5 times 2 to the x power. Notice it's going to be asking us some questions. Well, we don't know those answers, but what do we have? We have a table and we have a graph. And so what we can do is come over to our Desmos tab. So let me do that. And we're just going to type this equation right into Desmos. So let's come over here. And here we go. It's not letting me get off the page. All right, so hang on just a second. There we go. All right. Maybe not. Oh, why no? It's not letting me move. There we go. Nope. Okay. So I'm going to come right up here and do y equals, and I'm going to try to put in my equation, which is 5 times 2 to the x power. So let me just minimize that. That'll be easier. So I'm just going to type in 5 and then parentheses 2. And now to get the x power, I'm going to use the power key. We've used this on our calculators in class, but what I'm going to use, if you'll look on your keyboard at the number 6, and there's that housetop key right above 6. So I'm going to do Shift 6, and you see what happens is it sends the cursor up as a superscript, and now I can put in the letter x. Look what happened. Look what the graph did. Look at that red graph. That is an interesting curve. It's not a line, and it's not a U-shaped curve. It's what we call a J-shaped curve. And the nice thing about Desmos is you can take the graph and move it around. Now I've lost it. Where'd he go? There he is. There he is. Okay. So he seems to be flat on this side. Look at there, almost like a line. And then we get this bend, and then it seems to just go straight up. So if I zoom out, hey, it almost looks like the corner of a rectangle. But if I zoom back in, I can see this interesting curve. And so the problem already told us that it was exponential, and it is. And so now we have to figure out how that table might work. So instead of having you fill in the table by yourself or by hand, we're just going to let Desmos do it for us. So we're going to come up here to where it says plus, and we want to add a table. All right, so let's put some values in, and we can use this table to fill in our table that is right here. All right, so we're going to start. With the number 0, and when x is 0, oops, that's not a 0. When x is 0, what does it appear that y is? Let's look. Well, if I zoom in a little bit closer, maybe that I can see that when x is 0, y is what? 5. There it is. Yep, there it is. So when x is 1, let's see. I think that it is, what do you think? Let's just come and see. What does it say? Looks like what? 10. Okay. Yep, there it is. Okay, so now we could fill in our table a few more times, 0, 1, and we can just go ahead and do 0, 1, 2, 3, 4, 5, except for it looks like pretty quick. Look at here. This says that the x-axis stands for time and hours, and the y-axis stands for number of cells in hundreds. Okay, that's good to know. In hundreds. I almost missed that. So when x is 0, y is 5, so that means what? 500. When x is 1, y is 10. All right, so let's see if we can't get a few more. Let's see, some here up here, it lets me, that's not what I want. I think somehow I can change it to a table. Aha, that's what I wanted to do. I took that equation and I just changed it to a table. So what do we have here? When we've got these negative values, and then look what it did. It took the points and plotted them. When x is 1, y is 10. When x is 2, y is 20. Hey, let's look. What seems to be happening here? Do you notice a pattern? 1.25, 2.5, 2.5 to 5, 5 to 10, 10 to 20. Ah, how is that growing, y'all? Because look, the x values are changing by 1. Plus 1, plus 1, plus 1, plus 1. But look at over here at the y values. Plus 1.25, plus, no, not 1.25. What is it? Plus 2.5, plus, no, not 2.5, plus 5. They're not adding the same thing each time. How are they changing? Can you tell? Can you see what's happening? 2.5 to 5, 5 to 10, 10 to 20. What's it doing? Think. Okay. So let's go back to our table and see if we can't extend the table and figure out the pattern. All right. Now, when I had to go to the other screen, I lost my pen, but here we go. How many cells did we start with? And what that means is when x is 0, what did we have? You can go back and look at your table if you would like. When x is 0, in other words, right here, how many did we have? Go back and look. What was it? It was 5. And not, that was what? Hundreds of cells. So 500 cells, all right? At the very beginning, how many did we start with? We started with 5. So start with means what? When time or x, and you remember that I told you that in Algebra 1, if time is involved, it will always be x. We're not going to put time as y in Algebra 1. When time or x is 0 is our starting point. And how many did we have? 5. Or in this case, what? 500. Because that's what the y-axis does over here. Cells in hundreds. Time in hours. What's happening to the number of cells? Well, let's go over and get those values. When x is 1, y is 10. When x is 2, y is 20. So if we are looking at this, now what? Sorry, got a phone message from somebody in a different class. When x is 3, again, what's happening? 5 to 10, 10 to 20, it's doubling, multiplying by 2. So 5 times 2 is 10. So not plus 2 this time, but times 2. Times, that's a dot, okay? 10 times 2 is 20. So 20 times 2 is going to be, let's use a different color, 40. And then what? 40 times 2 is going to be 80. And then 80 times 2 is going to be what? 160. Do you see how fast that's growing? That is exponential growth. It's doubling. Every 4 hours, it's doubling. And that's one of the reasons that the virus, the corona-19, is so scary, because it grows so rapidly and each person can infect 3 other people. What is happening to the number of cells? The cells are doubling. They're being multiplied by 2 every 4 hours. Let's see if we can't plot some of those. When x is 0, y is 5. Put a big old fat dot there. When x is 1, y is 10. And what do you notice? Well, very quickly, this chart isn't helping us, is it? Because what? The next one's 20. Well, that's way up here. When x is 2, y is what? About 20. Yeah? And then we could take a different color. Now I can't get to those, but we could take a different color pen. And if we look back at our graph that we did on Desmos, we would see what? That it would be coming over here and flattening out, right? How many cells do you predict will be present after 8 hours? Let's predict. 5 is 160, so that means 6 is twice of that, so 320. And then 7, twice 320, so 640. And then 8, twice 640, which would be 1,280. That would be 100 cells, wouldn't it? Wow, that's really growing fast. And that's what makes it scary. But you know what? One of the reasons that math is so important is it lets us figure out stuff like this and predict, and then hopefully use that to share with people so that they will change their behavior. This is why it's important that we're not out around other people so that we're getting other people infected or that they're infecting us. All right, exponential growth, example 1, biology. We'll do another example in just a minute.